Assalamu alaikum, students and friends. In today's episode, we revisit thermochemical reactions, focusing on calculating the change in enthalpy associated to a given balance equation. So stick around, watch and learn. The question is, when 1.42 grams of iron reacts with 1.80 grams of chlorine gas, 3.22 grams of ferrous chloride, which is in solid form, and 8.60 kilojoules of heat is produced. What is the enthalpy change for the reaction when 1 mole of ferrous chloride is produced? When we say change in enthalpy, denoted by delta H, we are referring to the amount of thermal energy that is absorbed or evolved in a reaction carried out at a constant pressure. A positive delta H means the reaction is endothermic, while a negative delta H means the reaction is exothermic. Enthalpy changes are typically tabulated for reactions in which both the reactants and the products are the same conditions. A standard state is a commonly accepted set of conditions used as a reference point for the determination of properties under other different conditions. For chemists, the IUPAC, or International Union of Pure and Applied Chemistry, standard state refers to materials under a pressure of 1 bar or 1 atmosphere and solutions at 1 molar, right? And a temperature of 25 degrees Celsius or 298 Kelvin. But this temperature is not necessarily considered the standard, but is commonly practiced. For example, when liquid ethanol reacts with, or 1 mole of liquid ethanol reacts with 3 moles of oxygen gas, producing 2 moles of carbon dioxide gas and 3 moles of liquid water, okay, the amount of delta H, all right, or the standard enthalpy change, okay, denoted here by delta H with a superscript 0, right? The superscript 0 suggests that we're talking about standard enthalpy change values. So for this type of reaction, it is equal to negative 1366.8 kilojoules, right? And we say that in writing thermochemical reactions such as this, okay, uh, we need to specify, okay, the enthalpy change, whether standard or not, in the equation. And also the state of the substance for both the reactants and the products also have to be specified, uh, such as for ethanol, we specify here that it is in liquid form, and oxygen is in gaseous form, as well as the product carbon dioxide is in gaseous form, and water is in liquid form. The reason is that uh, delta H, or the enthalpy change, okay, depends on the state of the substance. In other words, a given substance will have different uh, enthalpy change or standard enthalpy change depending on their states. And we also stress here that enthalpy change is an extensive property, right? That means if in one given reaction, 1 mole of, say for example, ethanol, okay, produces this amount of change in enthalpy, right? And if you're going to multiply the number of moles of ethanol, say for example, by 2, then the amount of the enthalpy change will also be multiplied by the same factor. So don't forget to include this delta H, or enthalpy change, okay, of a given thermochemical reaction equation. Moving on to our solution of the given question, all right, we write the balance equation, which shows 1 mole of solid iron reacting with 1 mole of chlorine gas and producing 1 mole of the product ferrous chloride, which is in solid form. And we are provided with masses for iron, 1.42 grams, and for the chlorine gas, the mass is 1.80 grams. So we find the mole equivalent of this amount of iron, all right, 1.42 grams, okay, by just dividing it by the molar mass of iron, right? That is 1.42 grams divided by 55.8 grams. So we get the number of moles, or equivalent uh, amount of moles of 1.42 grams, which is 0.0254 mole. Likewise, the mole equivalent of 1.80 grams of chlorine gas, which is 1.80 grams, divided by the molar mass of chlorine, or 70.9 grams, right? So that gives us the mole equivalent of 1.80 grams of the chlorine gas, equal to 0.0254 moles as well. So notice that the stoichiometric ratio of iron to chlorine is 1:1, right? The same ratio, right, as what is shown in the balance equation, right? The number of moles of iron here is 1, and that of chlorine gas is also 1. So their ratio is 1:1, similar to what we obtain, right? Okay. As the stoichiometric ratio. Also given in the question is the actual amount of the product, ferrous chloride, that's produced equal to 3.22 grams, as well as the delta H or the enthalpy change, okay, uh, equal to negative 8.60 kilojoules. So our target variable in this problem is to determine the enthalpy change, right, of the reaction if 1 mole of ferrous chloride is produced instead. So we first determine the mole equivalent of the amount of the product, 3.22 grams of ferrous chloride. And that is simply dividing 3.22 grams by the molar mass of ferrous chloride. 3.22 grams divided by 126.7 grams. And so we get the mole equivalent of 3.22 grams of the product ferrous chloride equal to 0.0254 mole. So again, notice that the same number of moles, okay, is produced as the product, just like the actual number of moles of the reactants. Using ratio and proportion, right, we can determine uh, the enthalpy change, okay, which is our target variable, uh, delta H, okay, over 1 mole of ferrous chloride, right, equal to negative 8.60 kilojoules over 0.0254 moles of ferrous chloride. So, isolating and solving for delta H, we get delta H equals 1 mole of ferrous chloride multiplied by negative 8.60 kilojoules over 0.0254 moles of ferrous chloride. So doing our math, all right, we find the enthalpy change, all right, delta H equal to negative 339 kilojoules. This is if the amount of the product solid ferrous chloride happens to be equal to 1 mole. So our complete thermochemical reaction equation, therefore, okay, is given here, right? 1 mole of solid iron plus 1 mole of chlorine gas, producing 1 mole of solid ferrous chloride, and the amount of delta H or the enthalpy change being equal to negative 339 kilojoules. So on that note, may I say mabuhay. Till the next episode, MashaAllah. Thank you very much for your indulgence. Please don't forget to subscribe to my YouTube channel. Alhamdulillah.